right, another application of right triangles deals with something called a bearing. So sometimes when you're working with navigation or surveying, you'll hear people talking about or using the word bearing. And so it turns out to be a very specific way of indicating the location and the direction that you're going to be going. Okay. And you always wind up determining the positive acute angle. So you don't worry about whether you went clockwise or counterclockwise. You always are going to use an angle that's going to be the positive acute angle between the north-south axis. So this would be north, this would be south, and the terminal side of your angle. Okay, so you always report the acute angle between the north-south line and the line that shows the bearing, okay, that you're going. Okay. All right, so we're going to do some problems just to kind of get the hang of it. So first off, north is up, south is down, east is to the right, west is to the left. Okay. All right, so the first one I thought I would do is from O to B, because it's actually set up the way it needs to be. See, we are given 40 degrees, which is the angle between the north-south axis and the ray that creates your angle. So for that one, what you do is you report whether you went north or south. So we went north. Then you report that positive acute angle, which is 40 degrees. And then you report whether you went towards the west or whether you went towards the east. So it's towards the west. So the first letter is either an N or an S. In the middle, you have your positive acute angle between the north-south axis and the ray that you see. And then the last thing is either an E or a W. Okay. Now, the reason I didn't start with from O to A is because it's a little trickier. Because see, that 20 degrees is not the angle that you need. So you'd have to find this one, and you know that's 90, right? Right there. So if that's 20, you know this is 70 degrees. And so from O to A, you should say that you went north 70 degrees east. Okay. All right, let's look at from O to C. All right, so it'd be real easy to use the 75, but you see how that's not the angle with the north-south axis? So just like on the other one, you have to determine that angle, which is 15 degrees. And you see, to go from our origin, the bearing from the starting point to C would mean we'd have to go south. So we're going to start with an S, 15 degrees to the west. Okay. And then from O to D, we also went south, didn't we? And then the angle they gave us really was the positive acute angle that we needed. So we don't have to do any subtraction, but we went to the east, didn't we? So it'd be south 25 degrees east. Okay. So south 15 degrees west, and then north 70 degrees east, and then north 40 degrees west. Okay, so really study that and think about that. To me, this guy right here and C, those are a little trickier because the angle they gave you was not the angle you should have used. Okay. All right, and then sometimes you're actually trying to make use of a bearing that's given to you in a word problem. Okay, so they might talk about some ship sailing from port with a bearing south 25 degrees east, and they might tell you how far he went and then ask you questions about that. Okay, so let me give you an example of that. So the next example we're going to do is number 6, the checkpoint number 6. And I would read the section to get a bigger picture of that. I'm trying to do a pretty quick video for you. All right, so with checkpoint 6, we're having to draw our own picture, so that makes it a little harder. Okay, so it says you leave the entrance of some hiking trails. So here's the entrance of a system of hiking trails. You leave the entrance and hike 2.3 miles on a bearing of south 31 degrees west. All right, so what you should do is you should draw your north-south and your east-west line. So you can imagine that bearing. Okay, in red, I'm going to do the bearing. So I leave there and I go south 31 degrees west. So I head south and then I want to go, oops, should have been west. I shouldn't have drawn it to the east. So south 31 degrees west. Okay, might have helped if I reminded us all about those. And the 31 is this right here. So that's 31 degrees, that acute angle. All right, and then let me not put an arrow on it right so short. Let me make it a little longer. And then we go along, we hike along that bearing for a while. Then it says the trail turns 90 degrees clockwise, okay? Clockwise. So we're walking along here and the trail turns. So we're walking, remember we're facing this way walking, and the trail turns 90 degrees clockwise. So it's going to go like that, okay, at a 90-degree angle. So I thought of it just turning to the right, 90 degrees. And you hike 3.5 miles. So we're going to go, this right here was 2.3 miles, right? So this has to be a little bit longer. It has to be 3.5 miles. Okay, and it says you're hiking on a bearing of north 59 degrees west. So from the beginning of where you started that way, I'm going to draw another little mini axis so I could get the information. North 59 degrees, so this would be 59 right here, because that's north now. This is west, this is east. That would be 59 degrees. So I hike along for a little while there, and then we're asked some questions. So let me not make that too long, but I really don't know when I'm drawing it. So don't interpret too much based on the scale of your drawing, because you may not have your sides as long as they are relative to one another, okay? And then it says, at that time, how far are you from the entrance to the trail system? And then they want to know what the bearing is from the entrance to the trail system, okay? So what they want, let me draw it in blue, okay? What they want is this length right here, and they want to know what is the bearing that I'm traveling right there. Okay, if I followed that bearing, what is it? So they want to know from here to here, what's the length, and then also what's the direction basically that I'm going. Let me erase that back a little bit. Okay, so that's what we got to find. All right, so we can figure out the length of it pretty easily because we have a right triangle, don't we? So we can take the 2.3. We can take the 2.3 and square it, plus the 3.5 and square that. And that should equal this piece I'm looking for. I'll call it x squared, okay? So I'm going to work that out, 2.3 squared plus 3.5 squared. And I'll tell you what that is. That's x squared is 17.54. So now I need to do the square root of that. And I get 4.19. X is about 188 and so on. Let's see, they wanted us to round to the nearest tenth of a mile, so we can say about 4.2 miles. Okay, so we know the length of this right here is 4.2 miles. Okay, now for the bearing, what I've got to do, you got to really think about this now. We got to go back to that original axis that I had, and I want to know this angle from that north-south axis, so that little piece right there, that 31-degree angle, together with this little angle that's part of our right triangle that we have, okay? All right, so we got a little bit of work to do here. And so what you're going to do at that point is you're going to try to figure out, well, what can you do to figure out this little piece of an angle up here? Well, there's a lot of different ways you could do it. I'm kind of thinking about using the 2.3 and the 3.5 and maybe trying to find the measure of this angle right here. Just the little piece, okay? So not the whole thing. Let me do it in a different color. Let me do it in green. I'm thinking maybe what I could do is just find this piece, this little angle right here that's part of the triangle. And so if I think about that angle, 3.5 is opposite it, okay? 2.3 is adjacent to it. And you see this triangle I'm looking at is a right triangle. So what I could do is take tangent of that angle that I'm looking for, I'll just call it theta, equals 3.5 over 2.3, okay? All right, so I'm going to do that 3.5 divided by 2.3, and I get about 1.52 or so. Okay, really, I like to hold the whole thing in my calculator, so I actually kept all this on my calculator screen because I'm trying to undo it to get theta. So what I'm going to do is do the inverse tangent. I'm going to do tan inverse of all that I have on my screen. And I use second and the minus sign, which gives me second answer when I enter it. But I do second function tangent, and then I can pull that back up if I want by using second function and the minus sign, which brings back my last answer. Okay? Or if that doesn't make sense, just type 1.52 back in. All right, so what I get is about 56.689. It has a whole lot more, and we're supposed to round to the nearest tenth, okay? And so I can round that to 56.7 degrees, all right? And this, remember you're in degrees, or make sure you're in degrees if you weren't. Okay, so that's the angle in green right there is 56.7 degrees about. All right, so I need to do the bearing. So from here, I'm trying to do the bearing for this ray right here. I would have to go south. I would have to go 80, 31 plus, I would have to do 31 plus the 56.7, which would be 87.7 degrees, okay, towards the west. Okay, so that would be the bearing. And the 42.2, the 4.2, I mean, was how far I walked or how far I was away from the starting point. Okay. So what is your bearing to the nearest a tenth of a degree from the entrance? And they said from the entrance, so I reported from here to where I was. So that's why it was south. I wasn't going from where I ended up back to the starting point. So you have to be careful about those kinds of details. Okay. So let me go ahead and stop that. I just wanted to give you a little bit of an exposure to bearings, and then we'll talk more about them by using the problems that are in the homework.